Chapter 2, Graphs, Charts, and Tables, Describing Your Data. In this video, we'll cover learning outcomes 1, 2, and 3 regarding frequency distributions, histograms, and joint frequency distributions. In a separate video, I will show you how to do these in Excel. A frequency distribution is a summary of a set of data that displays the number of observations in each of the distribution's distinct categories or classes. In our example here, imagine you're an employee at Petco and you want to know how many pets your customers have. So you ask 20 customers who enter the store. In this column, we will write the possible answers of 0, 1, 2, 3, or 4 pets. And in this column, we have a tally of how many individuals said they had 0 pets, 1 pet, and so on. On the right, we have our column for frequency, where we've turned our tally marks in this column into numbers. And we can see how many customers have 0 pets and on. Note that we are working with discrete data, which is data that can be counted. Recall we learned in Chapter 1 that discrete data is countable. For instance, we can count how many students are of a certain age. We can count the number of courses taken in spring 2019 per student. We can count how many late deliveries Amazon made last month. And we can count the number of touchdowns scored in a football game. When working with frequency distributions, we often want to calculate the relative frequency, which is the proportion of total observations that are in a particular category or class. To calculate the relative frequency, we're going to take the frequency, this F here, that's the count of our value that we're looking at for a particular variable, and then divide it by our lowercase n. Recall that lowercase n is our total number of observations or our sample size. Using our Petco example, the first step is to list all of our possible values under the column that says number of pets. In step 2, we counted how many people have a particular number of pets. So under the frequency column, it shows 4 people have 0 pets, 6 people have 1 pet, and so on. We can also see that we have a total of 20 people in our frequency distribution. We mentioned that 20 customers got asked in our story, and if you add up our frequencies here, it equals 20 as well. In step 3, we'll then calculate the relative frequency for each of our classes or categories. So for 0 pets, there were 4 people that said 0, and we divide that by the 20 customers surveyed. So when I take 4 divided by 20, we get a relative frequency of 0.2. We'll do that for each discrete variable. So each of these rows, we will take the frequency and divide it by the total to get its relative frequency. When you add all of the relative frequencies together, it should equal to 1. That way you know that you've done it correctly. If when you total them up, it does not equal to 1, then you should go back and double check your math. The textbook also covers cumulative frequency distribution and cumulative relative frequency distribution. Both are very similar to what we just covered. It's just that cumulative tells us to add up the values as we go through each class or category. I have not seen this used in business often, so we will not cover it in this course. In our Petco example, it was a small set of numbers that were discrete and easy to work with. In other situations, the variable could be continuous or discrete, in that we have a much larger data set and we'd have to group the data. With continuous data, the values are uncountable and it could be any value in an interval, like weight, length, or time. With weight, I can say something weighs 20 pounds, but I can also say something weighs 20.5 pounds, and I can get very granular with decimal values. With discrete data, recall it's where we can count and have many possible outcomes. Like with income, I can count how many people make $50,000 a year, or I can count how many customers enter a store per day. When working with large data sets, we want to group them into something more manageable called classes. In order to build classes, there are several criteria. You have to make sure that they are mutually exclusive in that they do not overlap. That way, an item that you're counting doesn't appear in multiple classes. They should also be all-inclusive so that our set of classes contains all possible data values and nothing gets left out. Classes should also be of equal width or distance, so the shape of the bars that we see are even, and there should be no empty classes. For instance, we have a distribution of temperature, and it's actually too many classes, even though the width of the classes are equal or evenly distributed. We see here there are too many, making it jagged, so you can't really see a good shape, and we have an empty class right here at the 52-degree mark. Too many classes can give a poor indication of how frequency varies across classes. In this example of the same data set, we have too few classes so that we can't see the distribution or its actual shape. It's just one big blob in the middle. Too few classes can hide or obscure important patterns of variation. Here's an example problem number 13 in our textbook. After the 2008 recession, many homes were foreclosed because the owners could not make the payments. We're actually going to be using the Foreclosures Excel tab with a sample of 33 residential properties and the total balance on the mortgage at the time of foreclosure. Develop a group data frequency distribution and interpret. So here's the Excel file that you'll be using for this chapter, and you can see that in this first tab right here we have the foreclosures data for our example. Recall that sample size is denoted by the lowercase n, which is another way of saying the total number of observations that we have. And we're told that the sample has 33 properties. It's right here in our story. You can also count it in our Excel file. So the first thing we have to do is to determine how many classes to set up. The general rule of thumb is to have somewhere between 5 and 20 classes. Then we follow the 2 to the k is greater or equal to n rule, where k represents the number of classes that is the smallest possible number that satisfies this rule. We'll just have to plug in some numbers by trial and error to find the best option. So here's my setup, and why don't we go ahead and try 5, 6, and 7. So I start with 5 because the rule of thumb tells us that we should have between 5 and 20 classes. There's no point in testing a smaller number like 3 or 4. So when I take 2 to the k, I'm going to plug in my 5, so I'll do 2 to the exponent 5 on my calculator. We get 32. 32 is not greater or equal to 33, so that doesn't work. Then we'll try our next number. We'll try plugging in 6 into our k. So 2 exponent 6 equals 64. 64 is greater than 33, so that satisfies our rule. Now I can keep trying with 7 and on, but I don't need to because remember our rule says that we want to find the smallest k that still addresses our rule. If I use 7 or more classes, we'll end up with having too many classes and it will look jagged like we saw earlier in the video. So we're going to go ahead and use 6 classes for this problem. In step 2, we need to figure out how wide to make each class. Remember that the classes all have to be the same width. So here's the formula to figure out the width. We'll take the largest value from our sample and subtract the smallest value from our sample and divide it by the 6 classes we determined in step 1. So if we look at the data set, it's already sorted for you. Our smallest number is up here and our biggest number is down here. So plugging it in, when we take our largest value minus our smallest value and divide it by the 6 classes we determined in step 1, I like to simplify in parts to double check my math. So I'll go ahead and just work with the numerator or the numbers on top here, and I get 248, 315 divided by 6. When I plug this into my calculator, I get 41,385.833. But since this is a messy number to work with visually in our chart, and it's also hard to say if you were trying to present this information to others. So what we want to do is round our width up to a nicer class width. Note that the homework will remind you to do this, but we will round up regardless of the value, because if you round down, then you end up adding an extra class and we'll end up with 7 classes. So that's why we want to round up to the nicer class width. So in this case, we're going to be asked to round up to the nearest $1,000. So looking at our value here, rounding up to the nearest 1,000 gives us 42,000 as a nice class width. In steps 3 and 4, we will set up the upper and lower boundaries for each class, and then count how many properties appear in each of these classes. Now this is where you get to use your judgment and decide where would be a good place to start. And in this example, I'm starting at 85,000, and then we go up by the class width of the 42,000 that we got in step 2. And I'll go up by 42,000 for each of our class widths until I get my 6 classes. And then from there, I can go to my data and count how many houses fall under each of these classes. In another video, I'll show you how to do this in Excel. Note that in the homework, it might tell you where to start, so use that as your guidance. So what we've created here is our grouped frequency distribution. Very similar to the Petco example, except our classes are groupings of numbers. Once you've set up your frequency distribution, it's helpful to graph it into a frequency histogram. A histogram's horizontal axis contains the classes, which has all the possible outcomes, and the vertical axis is the frequency for each possible outcome or class, or the count. Note that there are no gaps between our bars. This tells you that this is a histogram. Note though that the histogram that I've created here was done using Excel, so our class widths are different than if we did it manually. So on the last example, when we did it by hand, our class widths were a prettier number, but in Excel, the histogram function starts where it thinks it's best. But the general shape should be the same if you use the same number of classes, which is 6 in our example here. So a histogram tells us where the center of our data falls within a number line. Here's our number line. And it shows us the spread, or how wide it goes, and it shows us the shape. Is it symmetrical, or is it skewed to the right or to the left? This will be important when we get to Chapter 3. Now here are the instructions on how to do a frequency histogram in Excel, which you can watch demonstrated in the Chapter 2 Excel tutorial videos. Next, we want to talk about joint frequency distribution. Here's a joint frequency distribution where the data we want to understand has two variables. So that's the key difference with frequency distribution and joint frequency distribution. We now have two variables we're working with, and they can be qualitative or quantitative. Remember, we learned about that in Chapter 1. In this example, we've asked 12 customers if they are a pet owner and if they are a homeowner. The answer options are yes or no to owning a pet, and for home ownership, it's own, rent, or other. Other might be for those people that live rent-free with family or friends, or some other situation other than owning or renting. So the first step is to collect the data and put it into a table as you see here. Then we need to set up our table right here and count the joint occurrences to enter it into the table. The joint occurrence is how many times two particular variables occur together. First, we need to count how many people said yes to having pets and own their own home. So if we look here in our data table, we can count that there are 4 people who said yes to owning pets and own their own home. Then we want to count how many people said no to having pets and own their home. And as I look through my table, I only see 1. Let's count how many people own pets and rent. So we'll look at my table here and we'll look for all the yeses and all the rents that go together. And we get 2. Then we need to count how many people don't have pets and rent. We also get 2. Lastly, let's count how many people own pets and said other regarding home ownership. So for those that said yes and other, we have 1 person. And for those that said no to pets and other is 2 people. For step 4, we'll go ahead and calculate the row and column totals. So adding up our numbers, we get 5, 2 plus 2 is 4, 1 plus 2 is 3, and then adding across the row, 4 plus 2 plus 1 is 7, and 1 plus 2 plus 2 is 5. And to double check, we want to add down this way, we should get 12. If I add this way, we also get 12. So this will make sure that we have accounted for everybody. We know that there were 12 people we surveyed and that we didn't miscount in any of our boxes. If your totals do not add up properly, you need to go back and double check. If we want to get to the joint relative frequency, we have to take the values in each of our box from the last slide and divide it by our total number of observations, which in this case is 12 customers. So we divided the 4 we counted earlier by 12, and we get 0.333. And we do this for each cell. Similar to our joint frequency table, we need to add up our numbers to find the total in our rows and our columns. So when I add these two, we get that, and so on. And adding across, we get these numbers. And then to double check our math, again, adding up our totals here and here, we should get 1. In addition, if you add up all the joint relative frequencies of our possible combinations, these also equal to 1. If things don't add up to 1, you'll want to double check your math again. If you have any questions, just let me know.